Okay, guys, this next lecture is going to be drawing kinematic graphs, and this is going to be a visual representation of what we studied so far with our position, or displacement, and our velocity. So these are kinematic graphs. Okay, and there's two kinds that we're going to start with. There is a position time, which is an S versus T. Okay, and there's velocity time, which is V versus T. Okay, and so we're going to start with position time, and here's our first scenarios. We're going to have, we've seen, all right, so we're going to have a number line here, or a position graph, right, with just a one-dimensional one, and we have a box because we like boxes. Physics teachers love boxes. I'm going to move that over here. Okay, and we're going to start at position 0, and we'll have 5 meters over here and negative 5 meters over here. And because we like boxes, all right, and we're going to put that right there at position 0. So we're going to measure from the right edge of the box. Okay, so if this box is stationary, all right, if it's just sitting there, okay, so we have a stationary crate at S equals 0 meters. Okay, and as time goes on, it's not moving, and so this one is actually very simple. So we're going to create a graph of this, and we're going to start with the obvious cases, and then we're going to get into the more complicated ones. So we're going to start with okay, so there's our graph. And so if this is at 0, okay, it's at 0 meters and it's not going anywhere, okay, then its graph is going to look like right, it's just going to look like that. That's it. It's position, right? If this is 0 right here, and this is our position time graph, position versus time. As time goes on, it is at 0 the whole time. Okay. Right, so that's the trivial version. So now we're going to try a different one. We're going to make it blue, and it's going to be, it's stationary. Stationary at position equals negative 3 meters, right? So in this case, it's going to be, oh, I don't want that. I'm going to select that. Select it, and we're going to move it 3 meters this way, right? So that's going to be about 3 meters, I figure. So it's 1, call it 2, 1, 2, 3, 4, 5. Right, so move that right there to about 3. Ends at negative 3, right? So it's negative 3, negative 4, negative 5. So we're stationary at s equals negative 3 meters. Okay, so what's that going to look like on our graph? Well, we'll take our, so it's going to go negative 1, negative 2, negative 3. Okay, and because it's still not moving, it's just staying there as time, so its position is not changing. I need a better. Okay, as time goes on, its graph looks like that, right? Because its position equals negative 3, and time continues, so that's, it's flat. It's stationary, and so its position is not changing. But what if we do change up our situation? We're going to go green here. Okay, and that our velocity, okay, now we do have a changing situation. We're going to have a velocity, okay, and our velocity is going to be, let's do 2 meters per second. Is a positive 2 meters per second, and its its initial position is going to equal negative 5 meters, right? So we would move this crate all the way back here to negative 5, and so that's going to be 1, 2, 3, 4, 5. It's going to be down here on our graph, and we can zoom in on that a little bit. And our velocity was plus 2 meters per second, so that means that for every second we're going to increase by 2 meters. And so that leads us to a position time graph that looks something like that. All right, so that after 1, 2, 3, 4, 5, 6 seconds, we should have increased by, so that's, sorry, this is negative 5, right? So 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6. 6 seconds. One, 2, 3, 5, 6, 7. Did I miss? I think I did. Oh, I went over 3. No, that's my bad. There we go. That looks much better. All right, so that's going to be up 5 and 1, 2, 3, 4, 5, 6, 7. That's much better. Okay, and so that would be our velocity. Every 2 seconds we increase. Every second we increase 2 meters. Okay, and this would be our position time graph. Okay, if we are traveling at 2 meters per second. All right, so let's try a different one. Let's try our yellow one here, and let's do a velocity. Its initial position. Let's do initial position first. So its position, okay, so S naught is going to equal 0 meters, but our velocity is going to equal negative 0.5 meters per second, or negative 1/2 of a meter per second. Well, if we're starting at 0, we're going to be here. And instead of, all right, so now we're going to move into 0 and then every 2. So we're going to go, yeah, we're looking at that right there. Did I get that right? Yeah, it looks pretty good. Okay, so what can you tell me about our velocity having a positive 2 meters per second, one of them having a velocity of positive 2 meters per second, and the yellow one having a velocity of negative 5 meters per second, negative 0.5 meters per second? Well, the green one's going up, and the yellow one's going down. And not only that, but these guys right here, these numbers, okay, our velocity is the slope of the position time graph, S versus T. All right, so in fact, these two, because this is the negative reciprocal of that one, these two are actually perpendicular to each other, but that's just a harken back to your math, All right, so what else can we say about these two values? That if the velocity is positive, then it is increasing. Okay, and if it is negative, then it is decreasing. Right? Not only that, it's possible to start from a negative position and have an increasing velocity, or we could start at 0 and have a decreasing velocity. But also take a look at this one. Okay, we're going to have a new initial position, where S naught is going to equal a positive 4 meters. But our velocity is still going to be negative 0.5 meters per second. So all that is going to do is 4 meters. So 1, 2, 3, 4, right there. Okay, so notice that this slope, that this velocity is the same as this velocity. And so if you look at the graphs just shifted up and down based on what its initial position was, right? So this initial position, that's your y-intercept if you're graphing the line. Okay, but the thing to know is that, this red one is decreasing because it has a negative slope, but we can move it up and down the graph, and these two actually look the same because they have the same velocity. Okay, so that is the big deal for this particular lecture for now. We will get more into it when we start changing our velocity. But the big thing to know is that if we have a stationary crate, if our crate is stationary, that means our velocity equals 0. Okay, which means there's no slope, which means it's horizontal. And if we have a positive slope, it's going to increase. Negative slopes will decrease, and they can be moved up and down based on their initial position. Okay, so that should be enough for now, and we will get back to, we will come back to this when we start talking about acceleration. So please record this into your notes, and we'll see you on Friday.